Hello everyone. My name is Ann Pilley and I'm a master's student working under Dr. Zmo. The topic of my presentation today is photo-initiated chemical vapor deposition. Photo-initiated chemical vapor deposition is a surface modification technique. Broadly, surface modification techniques are methods that are used to change the surface chemistry of an object or add a coating. Surface properties such as surface energy, adhesion, biocompatibility, and hydrophilicity can be changed by this process. Chemical vapor deposition, also called CVD, is a process where vapors react to deposit a thin film on a surface. Different surface properties can be targeted by using different gases. CVD has many advantages, such as creating uniform films with very few impurities or unreacted precursors. It does not require a solvent, and this therefore creates less waste. And finally, it can be used on irregular surfaces. It is currently used for semiconductors and integrated circuits. Photo-initiated chemical vapor deposition, which I will be calling PICVD from now on just to save time, is a form of initiated CVD. CVD can be initiated by three things: plasma, heat, or UV light. In PICVD, UV light creates free radicals which perform free radical polymerization. This can be done using a monomer that will react with itself or a monomer that will react with an initiator that reacts with the UV light. So the reaction that is relevant to my work is fairly simple. First, a sample is placed in a clear sealed reaction chamber. The reaction chamber is purged with an argon gas and the pressure inside the chamber is adjusted. Positive or negative pressure can be used, and it generally varies between 0.75 and 1.25 atmosphere. UVC lights are then switched on, and a hydrogen-carbon monoxide mixed reaction gas, called syngas, and a hydrogen peroxide photoinitiator are fed through the system. The system is then allowed to run for a set period of time. The important parameters of the system are the feed gas, the pressure of the system, the time that it runs for, the position of the sample in the reactor, and the age of the carbon monoxide cylinder. Varying the distance of the sample from the feed gas inlet or the pressure of the reactor will affect the hydrophilicity of the coating. Changing the feed gas allows for the targeting of different surface properties. The thickness of the film is directly related to the time that the system is allowed to react. The longer the system reacts, the thicker the film. Finally, as carbon monoxide cylinders age, there is meaning that they are allowed to sit unused for a certain period of time. The carbon monoxide reacts with the metal inside the cylinder to form iron pentacarbonyl. This compound is photoreactive and will react during the PICVD. This causes impurities in the film. It is therefore important to know the age of the cylinder that you are using in order to predict the amount of expected impurity. So PICVD has many applications. As previously stated, it can be used to create a uniform film on irregular surfaces, and it can be used to increase the hydrophobicity of nets that are used for pest control by apple farmers. These nets are used to create a barrier for insects. However, the nets tend to trap and store moisture, and this leads to a fungal disease called scabs on the apples. Increasing the hydrophobicity of the nets allows them to repel water and therefore decrease the occurrence of scabs. PICVD can also be used to apply films such as PHEMA films that are used in biomedical research and can be used to make different objects much more biocompatible. So how does PICVD relate to my research? My research focuses on the use of bio-based hydrogels for the removal of contaminants from wastewaters. Hydrogels are 3D polymeric networks that can absorb and hold up to thousands of times their own weight in water. They can be made from synthetic or bio-based sources. I will be using PICVD to modify the surface of my hydrogels and to see the effect that this modification has on the swelling rate and the final swelling capacity. I will also be testing to see if the surface modification affects the ability of the hydrogels to remove contaminants from wastewater. On the right, you can see pictures from my actual research, and you see that the coating increases the hydrophilicity of the hydrogel. These are my references. Thank you very much for listening to my presentation, and please let me know if you have any questions.